Hey everybody, we're going to do a quick video on how to multiply polynomials. We're going to multiply polynomials of all different sizes. So monomials, binomials, trinomials, polynomials. So get ready to go. We're going to start with our simplest one, but we're going to recall what we knew about or know about adding and subtracting polynomials. So if you look at problem number 1, I am adding 7x to the third plus 5x to the third. In order to add these, I have to have the exact same exponent with the exact same variable. So I could actually add these together, which means I have 12x to the thirds, right? I have 7 in the first group and 5 in the second group. So when I put those together, I have 12. In the second one, now I am multiplying. Now you'll notice I have the exact same terms here, but what's interesting is that I have multiplication between all of them. So I have no adding and subtracting whatsoever. When you are multiplying, you are allowed to rearrange the problem however it best suits you. So 7 times 5 times x to the third times x to the third is exactly the same thing as the first one that I had written. Writing it this way makes it a little easier to reason out what the answer is. 7 times 5 is 35. And now x to the third is x times x times x, and the second x to the third is x times x times x, so I really have x to the 6th. So what's kind of cool about multiplication is that you do not need to have the exact same term. We do need to have the same base though. But in this problem, I could multiply the 3 and the 2 together, and then because I have the same base, I could add those exponents together to get x to the 6th. Let's look at a couple other examples. Oh, let's write some notes and then we'll look at a couple other examples. So there's really two rules when multiplying monomials. You need to multiply the coefficients. Those are the numbers, those big numbers usually in front of a variable. And then if your bases are the same, you're going to add the exponents. Now remember, the bases have to be the same in order for that to happen. So a good example to have in your notes would be negative 3x to the power of 2 times 4x to the power of 5. I'm going to multiply my numbers and add my exponents, which would give me negative 12x to the power of 7. Let's look at a couple other examples here. I'm going to try a few and then you can pause and try the others on your own. When I look at problem number 1, I'm going to multiply my numbers together, which is negative 2 times 5, or negative 10, and then I'm going to add my exponents of my bases. Now I only have an x to the power of 2, so I only am left with an x to the power of 2. In the second problem, now you'll notice the parentheses, but the parentheses are the exact same thing as a multiplication sign. So I'm going to multiply my numbers to get 30, and then I'm going to add the exponents of my same bases. Now you might not notice, but there is an imaginary 1 on top of that y, and so I really have y to the 5th in that problem. Why don't you pause the video and try a few of these on your own and check your answers when you're done. You get these answers: negative 3x to the 9th, 12x to the 4th, y to the 3rd, and negative 10x to the 5th. Usually number 4 is the one that people have the most questions on, and just so you know, it would be okay if you had the y and the x reversed. However, usually in math we like to write things in alphabetical order, so the x coming before the y. You cannot add those exponents together because their bases do not match, but you can multiply the numbers. All right, let's try something else. Here we have a problem that you might have seen something similar to before, and typically when people look at this problem, they think about the distribution property, where I need to multiply that 3x to the 4th with all of the terms inside those parentheses, that other polynomial. We are going to do distribution, but I'm going to teach you an organizational method that will really help you multiply your polynomials and stay organized. Okay, I am going to use what's called the box method. The box method is where I set up a box that's the same dimensions as my polynomials. So this first polynomial has 1 term, and this second polynomial has 3 terms. So I made a 1 by 3 box. We could also make that box going vertically if you would prefer. But the big thing is once you get that box made, you're going to set your monomial on the side that has one box, and I'm going to set my trinomial across the top. I'm going to give every term its own box. Then, in order to figure out what goes in the box, I'm going to do a bunch of mini multiplication problems. So in this first box, I'm going to multiply 3x to the fourth with 2x to the fifth. The same rules apply as to what I just did. I'm going to multiply my numbers. 3 times 2 is 6, and I'm going to add my exponents to get x to the ninth. In the second box, I'm going to take 3x to the fourth, and I'm going to multiply it with the box that's right above it, negative 4x to the power of 2. Just like before, I'm going to multiply my numbers, so I get negative 12, and I'm going to add my exponents, get x to the 6. In the last box, I have 3x to the fourth, and I'm going to times that with the box right above it, which is 5. I'm going to multiply my numbers, 3 times 5, which is 15, and then I just have that x to the fourth. I don't have any other exponents to add to it. So my final answer here, if I were to distribute, or in this case use the box method, is I combine all of those little multiplication problems together to get my big polynomial. So 6x to the ninth minus 12x to the sixth plus 15x to the fourth. I cannot combine any of those terms together anymore because they don't have the same power with the exponent. So let's write an example of that in our notes. We have 2x squared times 5x to the fourth minus 8x to the third minus 7. I am going to set up a 1 by 3 box, and I'm going to put the single term, the monomial, on the side, and my 5x to the fourth minus 8x to the third minus 7 across the top. If you would like to show the little steps, you absolutely can, but we're going to multiply the things that meet in this box. So in this first box, I'm going to multiply 5x to the fourth and 2x to the second. That's going to give me 10x to the sixth. Then in the next box, I'm going to multiply 8x to the third and 2x to the second. Those are the two things that meet in that box. That gives me negative 16x to the fifth. And then in my last box, I'm going to have negative 7 times 2x to the power of 2, which gives me negative 14x to the power of 2. My final answer is when I add all of my boxes together in order to get the product of those two polynomials we had written above. All right, now we have a little bit different size polynomial. This is going to be done using the exact same strategies, but we're going to have a different sized box. So this first polynomial has 2 terms, and the second polynomial has 2 terms. So I am going to make a 2 by 2 box. This box is going to be otherwise known as a square. Now, what's important here is that I have to keep my polynomials together. So the x plus 5 has to go on a side by itself, and the x plus 8 has to go on a different side. I typically do the left and the top, but if you would like to do the right and the top, that works just as well. Now I'm going to have all these little mini multiplication problems. In this first box, I have x times x. This is usually one that gets people, but remember there's those little imaginary ones for your exponents there. So I have really 1 times 1, which is 1, but then I have to add my exponents, so I get x to the power of 2. In the next box is a little bit easier, 5 times x, or 5x. In my third box, I have 8 times x, or 8x, and then the last box I have 5 times 8, which is 40. My final answer is where I add all of those mini multiplication problems together to get the total solution for this multiplication. I can add like terms because 5x and 8x are the same variable with exponent to get 13x. Now, if you can handle that, you can really handle any multiplication problem that I might throw at you. But first, let's take some notes in our notes so we can have an example to look at. Oops. So here is a 2 by 2 polynomial or multiplication problem. So I'm going to make a 2 by 2 box. I'm going to put 2x plus 5 on one side and 3x minus 4 on the other. You do not have to put them in that same spot, but you do have to keep the 2x and the 5 together and the 3x and the minus 4 together. Then I'm going to do my little mini multiplication problems. I have 2x times 3x. I'm going to multiply my numbers to get 6, and don't forget to add those imaginary exponents to get x to the second power. Then I'm going to take 3x times 5. I'm going to multiply my numbers to get 15, and then I just have that x. Third box, I'm going to multiply 2x and negative 4, multiply my numbers to get negative 8, and then I just have that x. And then last but not least, I have negative 4 times 5, which will give me negative 20. My final answer is where I add all of those terms together and simplify if possible. So I have 15x and a minus 8x, which will simplify to a positive 7x. Here's one that is a little bit bigger, where again, we're going to use the same strategy. I have a 2-term polynomial first, and then the second one has 3 terms. So this time I am going to make a 2 by 3 box. What that looks like, at least the way that I usually do it, is a long box that I split in half and I divide it into thirds. I'm going to write my binomial on the side that has 2 boxes, and I'm going to write my trinomial across the top with 3 boxes. Now I have a bunch of mini multiplication problems again. So remember there's that little imaginary 1 on those x's. Sometimes it's helpful to put those in advance. But in this first box, I'm going to multiply 2x times x to the power of 2. That's going to give me 2x to the power of 3. Then I have 3x to the power of 1 times 2x to the power of 1, which gives me 6x to the power of 2. In the third box, I have negative 5 times 2x to the power of 1. That's going to give me negative 10x. Now in the second row, I'm going to be multiplying everything by that 4. So 4 times x to the power of 2 gives me 4x squared. Now I have 4 times 3x to the power of 1, which gives me 12x. And then the last box, I have 4 times negative 5, which gives me negative 20. My final answer is going to be where I add all of those terms up. Now we have 6 terms here, so we're going to have to be on the lookout for like terms in order to simplify. So just like we've done in the past, I'm going to start here and I'm going to say, all right, do I have any other x to the thirds? I do not, so I just have 2x to the third. Then I'm going to look and I say, all right, I got a 6x to the power of 2. I can combine that with a 4x to the power of 2, which gives me 10x to the power of 2. Then I have negative 10x, which I can combine with a positive 12x. Negative 10 plus 12 is 2x. And then at the very end, with no like terms, is that minus 20 that we write all alone. And that is my final answer. We have a couple special cases to talk about, and these don't really involve learning anything new. It's more when it gets the final answer, something a little bit interesting happens in this problem. So I have x plus 4 times x minus 4. When I multiply these, I'm going to get x to the power of 2 in the first box, 4x in the second box, negative 4x in the third box, and then negative 16 in the last box. You'll notice when I add together all of my terms, something interesting happens, and it happens right here. when I have a 4x minus 4x, those actually cancel out or add to 0x. You do not have to write 0x, so usually we just leave it out and we write x squared minus 16. This is called the difference of squares, and it's just a situation where your two middle terms end up canceling. Another special case is where it looks like we do not have multiple polynomials. So this just looks like 3x minus 1 to the power of 2, so just one polynomial. But if you remember, we've talked about this, when we have something raised to the power of 2, for instance, if I had 3 to the power of 2, that's the same thing as multiplying 3 times 3, or 3 times itself. So 3x minus 1 squared is the same thing as 3x minus 1 times 3x minus 1. Once I write it with multiple polynomials, I can use the box method to set up my multiplication problem. So I would get 9x to the power of 2 minus 3x, and then a positive 1. This time, when I add all my terms together, it kind of looks like we might get cancellation, but those middle terms do not cancel. They actually can combine together to give us negative 6. All right, so finishing out our notes, we're just going to write an example of a perfect square as well as a difference of squares, so you have those in your notes. So if I had x plus 3 squared, thing you need to know is that x plus 3 squared is x plus 3 times x plus 3, and then you can go forth and use the box to get x squared, 3x, and 9. Remember, we get that x squared in that first box because we have the little exponent of 1 that we are adding together for both of them. I'm going to combine all my terms together, simplify if I can. It's very similar to any other problem we've done in these notes. Difference of squares is the one that looks a little bit, or ends up being a little bit more fun. So 2x plus 1 times 2x minus 1. You'll start to notice these because you have binomials that look exactly the same, but one has a plus and one has a minus. So 2x plus 1, 2x minus 1. This is going to give me 4x to the power of 2, 2x, negative 2x, and negative 1. This time, when I add all those together, the middle two terms cancel out or add to 0x, so I get 4x squared minus 1. If you would like to, you can add this, try this in your notes that you can try on your own, and we can talk about it when we return to class. Good luck!